Testing 1, 2, 3. Testing 1, 2, 3. Testing 1, 2, 3. Testing 1, 2, 3. It looks like we're live. Testing 1, 2, 3. Alrighty. What time is it? It's 2:30. And it's Thursday. It feels like Friday. And I need to do some work. Let's see. I want to double check the sync on this because it was like Friday. And I need to do... Yeah, it looks like it's kind of working. Not why it's so choppy though. So, okay, what are we going to do? We're going to do some JavaScript development. And this is for a project that's educational. It involves Node.js, it involves browsers, it involves WebGL, it involves applications talking to each other and not blowing up. And we have a extension to this that may last 3 years. I lost my beverage. Dang it. Where's my beverage? The whole point of starting this was to have a beverage. Let's deploy the desk into standing mode. Because when I'm sitting down, I feel like going to sleep. I'm just going to stop it. Alright, at least we're standing up. That's a start. Oh, look, the kitty's behind me. Where did I put my drink? I was here a moment ago. I'll be right back. Can't start without a drink. I know it's up here somewhere. Poured myself some nice ginger ale. But while I'm going up here, let me think about what I want to do. Just started evaluating the next series of architectural changes that need to occur before, well, I guess that need to occur. There's quite a few of them. One of them is being able to reflect the main display running in the main browser to other browsers that are running on iPads. Now, before, what I thought I could do was I could reflect the piece updates from or rather the game rendering loop from the main browser, just broadcast them to everybody else. But after thinking that through, I don't think that will be able to work because of certain special cases that rely on so not very well controlled random number generation on the browser. So the simulation will deviate from on the browsers as it will the other iPad browsers versus the main browser. Now, theoretically, you could fix that. So it's but it's potentially a big hairy pain in the butt because you're going to have to now nail down every single use of random. You're going to have to start authoring things for maximum stability. And that actually takes away from the goal of the software, which is a very rapid research and development environment. We're not delivering a polished multiplayer game experience. We're delivering a prototyping system that will allow us to create research scenarios that can be tested, not like months and months, although that's how long it's taking now, but ideally in a matter of days. And therefore, I had to refactor the way I'm thinking about this. So instead of actually trying to distribute the display processing, the intent is you want to be able to reflect what's happening on the main screen on the iPads. It's not to run a game simulation in sync with another simulation. And it's not to have a distributed simulation or a multiplayer world. Basically, I want to mirror video, and I've avoided it for a long time because I didn't want to write a video server, knowing anything about it. But in the time since we started this project a couple of years ago, vast advances have been made in WebRTC, which is this, I guess you could describe it as a collection of browser technologies that allow you to access microphones, web cameras, and connect, do a peer-to-peer connection with another browser, and then have video chat. Before, this used to require plugins and fancy stuff like this. Flash was the first, I think, widely deployed technology that allowed this to happen. And so you needed the Flash plugin, but now Flash is not cool anymore. HTML5 now has embedded these kind of things into the browser technology. It's just not been very well documented until, I think, pretty recently. I was looking at some of the more recent example code that did not exist 2 years ago, and it seems like a lot of things have resolved. Some of it is quite still experimental, but for the purposes of this project, so long as we stay within the Chrome browser ecosystem, we should be okay. So that's my thinking on this anyway. So having said that, there are a number of different architectural challenges to meet. And I need to think about how I want to tackle all of this. I also want to think about how to split this work up so I can hire some other people to jump in on some of these subsystems. Ginger ale. Alright. So now that I've kind of warmed up my thinking on this, let me think about how I want to really make use of my time today. Let me just pull up, I'm just pulling up some browser related stuff. My timesheet. Let me check something here on the stream. I downgraded all my camera resolutions in an attempt to make it run a little bit faster. It looks okay. Quality looks good. A little bit blurry, but that's probably better for me since my complexion isn't that wonderful. Also, I kind of like this view, like with the letterbox look. That looks kind of hot. Probably better for me. Otherwise, I'm hearing popping now. Also, I kind of like this view, like the letterbox look. That looks kind of hot. That's not so bad. A little bit of echoes. Anyway, let me pull up my desktop and let's start looking and see where I left off. So here I'm looking at my, this moved over again. Just 1 second, I need to update the accessibility settings yet again. I did this already once today. Picture in picture, adjust the size and location. Stay on this frickin' monitor. Oh, you know why it moved? It's because it's actually my fault. I just changed the connection of this monitor from HDMI to DVI because I need an HDMI output for something else. Alright, so over here on my notebooks, this is the Play project. Here are my notes on the Play. Here are the notes yesterday I did on sending the display to an iPad. Some WebRTC notes. Let me look at the development roadmap also. I haven't looked at this in a few weeks. We're in the October time frame now. Mail, October. Alpha Year 1 summary. So that's coming up soon. September. We got like maybe 6 weeks. And so we're getting into the meat of what this needs to do. Authoring. Annotations. This is dependent on having some of this distribution stuff working. Controls, properties. I'm not so concerned about this because I've thought of something I can do in the meantime, which is basically to make a bunch of games with this system that demonstrate these concepts. If they're not exactly the type of activities that the researchers and teachers want, but certainly could be adapted to them. And I can design that on my own. Then event streaming, we wrote this big system that unifies all the events and system inter application calls into one system that kind of works. So it seems to work really well. What I don't know is that whether or not it will work as if it will make things as easy as I think it will. It kind of is reminiscent of ES6 promises. Now that when I was reading up on that the other day, it says, "Oh, this is kind of what I'm trying to do to make the asynchronous call chains less hellish." Drawing, button presses, sliders. This is not something we're worried about because we have the I have that technology in place. But for things like the timeline display, we already did these chain reactions. This is all done. The feasibility of video annotation, running a video server with WebRTC, that looks like it might be more doable than I thought. This GUI stuff is probably I'm going to have to just jump in and start designing something I think will work. Let's see. This table's a little too low. It's better. Okay. It's a little bit high. Trying to get the keyboard so when I'm typing on it, my wrists are straight. And then I'm not craning my neck in a weird way. Okay. Let me raise this. Hey, Squeaky. Who's the squeaky kitty? What's this stuck on? Alright, now I'm procrastinating by fiddling with this camera. Alright. Meow. Okay, now I gotta start my timesheet now. Today is Thursday, September 8th. I'm just fiddling with my screen here on the right side, which you can't see. You can see it here in the little bottom camera view. But probably it's really blurry. It's alright, because it's really boring. Yeah, it is now 14:45, let's say. What did I say I was going to do today? Yesterday I was talking to Ben. And what did we talk about? We talked about... Well, I talked about the difficulty in doing the sync that I thought it would, the way I thought it would work, and then making a distinction between the use cases. It's not that we want to make the simulation run on the remote as closely as possible. We want it to look exactly the same. So the use cases really are, we can ship the actual data and its parameters, but the visualization itself doesn't necessarily need to match if we're just doing data analysis or writing instruments, things that are measuring. However, when it comes to providing the same reference between the main screen, which is this giant, 20-foot screen, versus the screen you're looking at on your iPad, those should have as close to a one-to-one correspondence as possible. Any discrepancy there will just lead to confusion. And trying to eliminate this discrepancy by taking a distributed display list approach is actually a lot of development time for relatively little gain in for terms of, I think, actual necessary function. And by that I mean that, sure, we could rewrite the display system to work in a distributed fashion, which was not part of the spec when we started this project. And to get the one-to-one fidelity would take, I think, a lot of time. There may be an intermediate point in which there's enough fidelity, but it's going to require some iteration and back and forth. I don't think it's a really good use of development time. what I would rather do is add more features that we can build on in the future. And so with that, I think now is the time to look at the WebRTC stuff. And what I understand about it now versus then is WebRTC is not a video encoder per se, but what it does is it takes a source canvas, which is the two-dimensional surface in which things are drawn on, and then it compresses it, uses a built-in encoder. So all I need to do is provide a canvas surface, and I can get that out of the WebGL module and just ship it across. So what I'm wondering is if I can make that work today. All right, so let's do that. Let me look back into our continuity notes. Yesterday I thought of working on the display list distribution, started thinking about it, thought it might not be the right approach because getting one-to-one correspondence is trickier than I thought. Whereas peer-to-peer WebRTC might be more doable. Also yesterday I was thinking about just the architectural approach. There's two things. Let me do this. Tech feature checklist, tech high-level goals, let's call it. Instead of relying on a spec from researchers, we can design our simplified version of the existing or the past activities. This decouples our need for specs from researchers and allows us to move ahead. We can do this now because we've had enough working experience to know the kind of things that have come before. We have history in the project, in other words. And then also, so design some mini versions of this as the foundation of our next level of prototyping. I think that sounds reasonable. Next, for our tech high-level goals, WebRTC may be preferable than trying to clone the render loop from the main display to a sub-app display. That's because the render loop in each app is very specific and it has tweaks that must be copied to the sub apps or the supporting iPad apps. So code reuse is a little tricky. However, if we just provide the means to mirror the display, that works with everything. So let's see. September 7. Wait, that's not right. No, this is right. No, today's the 8th, isn't it? What happened to September 7? I think this is, I don't think I actually did any work on this 5th. Double check that. Today's the 8th. Says I worked on 7th. Oh, I did do work yesterday. 6th. The 6th was all repo work. The 7th was display list stuff. Repo work. Oh, and no wait, that was the 5th. What was the 5th? The 5th was repo work. Oh, repo fix bugs in media cache. Alright. September 8th. What are we doing today? Let's see if see if we can get the WebRTC stuff working. First, let's look at some demos. I saw one specifically that was how to stream. I think it was this one. Let's look at it, why don't we? So the cool thing is click and drag on this canvas element here, and then it copies it to this. And it's not an extremely exciting demo, but it's also lagging a little bit. It says it's capturing from the canvas using its capture stream method. See the console browser to see logging. Oops. Refresh this. Remote video size change 240 by 180. Setup time 3 seconds. Remote video window width 240 by 180. As I reset the browser, nothing. Not a whole lot's going on there. Now I can inspect these from the console. That's neat. Let me move this aside. So it says canvas is available. Where is it? What is the name of this canvas? Where is the script? Yeah. There's the source. View source on GitHub. That's not what we want. I guess main would be it. Var canvas is equal to document set query canvas. That doesn't I guess that is global. It didn't seem to work here. Canvas and video. According to this though. Oops. Yeah. What the heck just happened? I see nothing. Do I have to inspect this like this? I don't think that's what they meant. Anyway, let's just look at the source code. Not here. I guess this is it. Stream canvas capture stream. Trace got stream from canvas. Call. Call what? Where's the video? Query selector video. I think we just want to print this out. So we have something called canvas and we have something called video, so there's only one of them. And pull up some, I want to take some notes here. I fixed all this stuff already. Alright, let's make some notes. So there's a canvas element and a video element. Video gets an event listener. Let me just make a note. Loaded metadata. You can set width, height. Your width. So once this starts running, after this asynchronously loads, on resize, what is it doing? Remote video chat change to video width plus video height. Use the first on-site callback to indicate the video started playing. If start time, elapsed time is window performance now minus start time. Trace setup time, elapsed time, blah. Call to main in demo.js. And call canvas capture stream. So I see, or did I see that before? We have a call function call starting call video. I guess it's calling the distance. So we have something called stream. Where'd my window go? Float. You should be floating. That's better. Stream equals canvas capture stream, and then we have video tracks equals stream get video tracks, and then we have audio tracks equals stream get audio tracks. Ugh. It looks to see so servers. Servers equals null. And then what we're doing here, PC1 equals new RTC peer connection servers, and then PC1 on ICE candidate E on ICE candidate PC1E, and PC2 is RTC peer connection 2. So those two PCs. Then there's a on ICE connection state change. PC1 on ICE connection state change. To on add stream equals got remote stream. This run it twice. Getting my limit for BS. Which in this case is I'm starting to keep track of a bunch of things that I'm not sure how they relate together. So let's let me try something here. What concepts am I seeing? Canvases have streams. Streams have video tracks and audio tracks. RTC peer connection returns something. I guess it returns a peer connection. Thing. There's this on ice candidate. There's on ice connected state change. There's on add stream. A wave of sleepiness besets me. Here's my drinks. Waves of sleepiness. What else do we have here? We have a number of different descriptors. Those are handlers. Methods. What are we seeing? We have add stream. We have create offer. Func error func options. PC1 create. So all this is happening in what? In this call. What does the call consist of? In call, let's see. Gets the video. PC1 PC2 creates two ICE candidates. I'm not sure what ICE is. Because on ICE candidate PC, on ICE connection state change. Calls on ICE candidate on self, calls on connection state change itself. Maybe to all that stream has got remote team. PC1, PC2, PC1, PC2, calls on connection state change on itself. Adds. Creates an offer. PC1 creates an offer. Which is where? Local descriptor, local submit, unlocal set. Looks like a demo. We'll see demo. That was main. Is it test.js? Let's tape. Is this ES6? Require, I think, is an ES6 command. Alright, so I've bored myself silly looking at this. What I want to really know is, what I want to know is how this ICE stuff is. WebRTC ICE. This looks old. Let's look in the past year. Understanding WebRTC connectivity. That sounds like it might be useful. Okay. A stun server performs a very basic job. Tells the client what its actual IP is. A turn server provides a fallback solution for clients that cannot establish a peer-to-peer connection. It's a media proxy. We don't want that, I guess. ICE candidate. ICE candidates are produced by the client during the ICE negotiation phase. It indicate the kind of connectivity has been discovered by running connectivity tests using stun and turn servers. Signal channel communicates connectivity between two peers. Man. I so much want to take a nap, but I am resisting. That smuts my eyes too. Okay. This has been 30 minutes so far. Here's a handy diagram. I'll save this in my Peer A and Peer B. Who am I? Systematic net. Channel, please. Answer SDP. As candidates A, candidate B. So he first creates ICE connectivity tests, figures out its IP and NAT status, communicates its own audio and video connectivity capabilities, retrieves audio from peer B, Okay, so it looks like the handshaking is figuring out who it is, communicating its capabilities, and getting the capabilities of the second one. Then it attempts to make a connection. Tries some stuff, and then tries to make the best connection possible. Ooh. 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 All right. Knowing a little bit more about that. Let's take a look at this again. So where's the main.js? I'm about to pass out. I'm so tired. So here's the call. This new RTPC connection servers. What it gets is system handlers receive ICE candidate data. So state changing on ICE candidate on state change. These are two events that fire. At some point, it executes this create offer thing. That you guys makes the connections. I guess all the parameters are in this peer connection object. So let's take a look at that. WebRTC peer connection object. RTC peer connection. What does RTC stand for? Real time something? Experimental technology. An RTC peer connection represents a connection with a local device and a remote peer. Properties can trickle ICE candidates. I don't know what that trickled ICE candidate is. Connection state, online description. Current remote description, default ICE servers. On add stream. On data channel. ICE candidate. No connection change. On odds gathering exchange. On identity result. When a website or app using RTC can use ICE can from a remote, it delivers the newly received browser's ICE agent. A media stream was added. Add track. adds to the connection. Ooh. I'm gonna conk out. I'm gonna keep awake. Let's sit down again. Ugh. Let me look at this code one more time. So, knowing that a PC WebRTC peer connection contains properties related to the connection to a remote server, what are we doing here? When I see an on ice candidate, what is this on ice candidate function? Here. Add. What's it on ice candidate? I don't think it's in the source file. Oh no, here it is. When it gets it gets the connection and it gets an event. You get other PC. Add ice candidate. New RTC ice candidate. Success and fail. Trace, success, fail. So this just gets, I guess on ice candidate is called for every candidate that appears. And registers the ice candidate by calling RTC ice candidate with a candidate data. But how does it know when it can run? So you're setting up these things. What's on local success? Where is this being called? What do I state change? PC2 on add stream. Get remote stream. So PC2 is our destination, I think. What's got remote stream? Is that a boolean? Got remote stream. Oh. So you're setting the video source object to stream. And then what are we trying to do here? We're gonna stop hitting this wall. I think I'm gonna stop streaming for a bit and sort of either take a nap, because I am like dying here, until let this percolate through my head a little bit. Maybe I'll do something physical to keep myself from falling asleep, but it's like I'm like cross-eyed trying to stay awake. So I guess I've hit my limit of confusion or uncertainty, you know, for doing this type of work. But later on, I'll take a look at this. It's starting to be, at least I know what a stun server is and what a turn server is. I know the basic method of doing the handshaking. What I'm not clear about is how that handshaking is conveyed to me in my app without running a computer to tell it it's overkill. Okay, I'm going to stop the stream for a bit. And I'm going to take a break. Where's my timer? Hey Siri. Hey Siri. Set timer for 30 minutes.
Okay, 30 minutes and counting.
Alright, I'm going to rest and see how I feel in about 30 minutes. Let me make a note of my timesheet. I started at around 14:45. It is now 15:20. Let's call it 15:15. Review WebRTC docs feasibility. That's 15. Actually, I'll take 15 minutes off that because reviewing the source code is like not. I don't think I will bill it for full rate. Alright, so that's that. Let's stop this stream now, and I will come back a little later.